Hello, this is Math Models, topic 1-5. Today we're going to be talking about theoretical and experimental probability. Well, experimental probability is probability based on collection of data. The key word is experiment. We have to actually do something. Theoretical shows what should happen in an experiment. Okay, this is what the probability that we've been dealing with so far. Experimental shows what actually happened. So let's take a look. Jim tosses a coin 35 times and records whether the coin lands on heads or tails. And here we have it. And so we want to find the experimental probability. Well, we would say that it's 1/2 if we were talking theoretical, but obviously he got more heads than tails. So let's count them up. 5, 10, 15, 20 out of 35 is how many times he actually got heads. And if we simplify that, we get 4/7. We turn that into a decimal and get 0.57. And as a percent, that would be 57%. And that's our answer because it would like it as all three. So that means tails, well, if heads was 4/7, the rest of them were tails, so that would be 3/7, which as a decimal is 0.43 approximately, and as a percent is about 43%. Now the theoretical probability of throwing heads we've talked about before is 1/2. There's one head and there's two sides, so that would be 1/2. And tails would be the same. And now we want to know what the difference between experimental probability of throwing heads and theoretical probability of throwing heads. And we want this as a percent to the nearest whole. Well, this would be the experimental being 57% minus the theoretical, which would be 50%, gives us a difference of 7%, which is really not that big of a difference. He just happened to throw heads a little more often. And so now here, you and a partner are spinning a spinner 30 times and recording our results on a tally. And we want to find the experimental probability. 1, 2, 3, 4, 5. There's 5 different options. And so I'm actually going to do this a little bit differently. I'm going to assign these numbers 1, 2, 3, 4, and 5. And I'm going to use a function of the calculator to do this randomly for me. And how I get there is I hit the math button. I scroll over to where PRB is. And the very first thing is rand. But that's not what I want. What I want is rand int. And I'm going to type in 1, 5. And now what this does is this will randomly generate a number between 1 and 5. Here I got a 5, so I'm going to put a tally mark next to the 5. And I'm just going to do this several times. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Five, 10, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30. And so I've done this 30 times. And now I'm going to record my frequency. So yellow was 5, 6, 7, 8 out of 30. Purple was 5, 6, 7 out of 30. Blue was 4 out of 30. Green was only 3 out of 30. Sorry. Purple was 5, 6, 7. Blue was 1, 2, 3, 4. Green was 1, 2, 3. And red was 5, 6, 7, 8 out of 30. Well, green or blue would be 7, 8, 9, 10, 11 out of 30. Yellow or purple would be 8 plus 7 is 15 out of 30. And red or blue would be 8, 9, 10, 11, 12 out of 30. And now I'm going to go ahead and just simplify all these. This would be 4 out of 15. That stays the same. This would become 2 out of 15, 1 out of 10, 4 out of 15. That would stay the same. This would become 1/2. And 12 over 30 simplifies to 2/5. And now, I want to find the theoretical probabilities. Well, theoretical would be there are 5 options. One of those options are yellow, and the other 5 total. There is 1 purple out of 5, 1 blue out of 5, 1 green out of 5, and 1 red out of 5. Well, green or blue, 1 plus 1, that would be 2 out of 5. So 2 out of 5. And 2 out of 5. And so if you'll notice, my numbers are not the same. These happen to be the same, 2 out of 5, 12. And so I would have expected to get about 6 in each category. I didn't get 6 in any category, but I was close for the most part, with green being way too low and yellow and red being a little bit high. So that is experimental probability, theoretical probability, and it should be fairly easy. Good luck and have a good day.